Hello, in this video we will work out two examples. One example will be utilizing the normal distribution to compute a probability, and the other example will be using the same information but to compute the probability for the distribution of sample means. So we begin with the following problem. It states that the average lifespan of a sparrow is around 3 years with a standard deviation of 0.87 years. If the lifespan of the bird is normally distributed, so that's informing us that we can use the normal distribution to compute the probability that the sparrow will live longer than 4.5 years. So we draw the normal distribution. The mean is 3. 4.5 is to the right of 3, and since it's saying more than 4.5 years, we wish to calculate this tail area. So the way that the problem is constructed, it's the probability that the variable is greater than 4.5. In order to compute this probability, we need to convert to a z-value. So 4.5 must be converted to a z-value. So we plug it into this standard z-value formula for the normal distribution. 4.5 minus 3 divided by 0.87. We always round to two place values. 1.72. Once we have the z-value, we then look it up in table E. So here's 1.7 and 2 is 0.9573. That always gives us the area to the left, but we want this tail area, so we compute 1 minus 0.9573, which is 0.0427, and thus our answer is that the probability is 0.0427. So we want to contrast this type of example with a problem involving the distribution of sample means. And we want to be able to distinguish between the two types of distributions. While the first clue that you're working with the distribution of sample means is the way that the question is posed. So we have the same information from the previous problem, but now it says if a sample of 20 birds, so right away we can determine that we are given a sample, whereas in the previous problem we did not have this sample, are collected. What's the chance that the mean of the sample is greater than 4.5 years? So the way that this question is phrased, that's letting us know that we're working with a totally different distribution. It's called the distribution of sample means. Now it has a normal shape, but every value on this distribution are different sample means that have been collected from the population and have been used to construct this distribution. And we represent this distribution or highlight it with the notation x bar, which is different than having the x value. So that's another clue. And also when we phrase the question, we're looking for the probability that the sample mean is greater than 4.5. Whereas in our previous problem, we had the data value is greater than 4.5. Thus, we have to use a different z-score formula to calculate z. Remember, x bar is 4.5, mu is 3, the standard deviation is 0.87, and we're dividing by the square root of the sample size, 20. This computes a value of 7.71. when we look up 7.71 in our table, we have to go to the bottom of our table where it states that any z value greater than 3.49 will have an area equal to 0.9999, and that's to the left. And finally, we calculate this tail area. 1 minus 0.9999 is 0.0001. So the answer is 0.0001. Thanks for watching this video.